Hi guys, this is going to be about experience in partnership between HPE and DDN, and this is about data tiering with Lustre. We have two technologies, DMF7 and Exascaler, that work together. So I'm going to talk a little bit about the parallel file system choices that HPE is offering. So we have our own community-based HPC storage based on Community Lustre that we that provides scalable architecture and runs on standard HPE DL380 servers Gen 10 and D6020 disk enclosures, essentially JBOTs connected behind the DL380 servers. The storage is based on ZFS file system fundamentally and is fully integrated and supported by HPE. For kind of a big boy commercial offerings, we have partnered with DDN, and this partnership has been going quite well for about a year. There's a rich feature set, including everything that DDN has to offer, and the product is available through HPE through a program called 3PO. So, data management. Why should you care about that? Well, there's three reasons why you might want to care about data management. First one is you have too much data. You have petabytes of data, which is unstructured files, and it's too expensive to keep. So DMF can actually tier that for you, in a scalable way to a variety of backends, including what we call high latency media. That's a nice name for tape. So the other reason you might want to care about data management is that you just have too many files, right? So you have too many files, and you deal with workflows that require you to stage those files for processing from time to time, and then you have to figure out what specifically you want to stage, and maybe you have labeled the files but you don't know what they are. So DMF can help you with that. It has powerful metadata search engine that can actually locate, select, and stage the files based on a set of extended attributes or other file metadata that you may have. And finally, if you have not enough IOPS, you may need a fast scratch storage where files can be placed for processing by HPC cluster or AI cluster, and DMF can manage that for you as well. In summary, DMF version 7.1 offers a comprehensive solution for optimizing storage utilization, streamlining data workflows, and minimizing storage costs. So what is exactly DMF? DMF is, first of all, it is a scalable HSM engine, but it's not just that. It's also what we call data management hub. It allows you to integrate your data management with the workflow that you have in your environment. It is also a POSIX to object bridge, and this is something that is difficult to pull off, and we do that using versioned metadata map that we create for mapping between POSIX namespaces and S3 namespaces. It is also a powerful data transfer engine. DMF has been around for over 20 years, and we have figured out how to transfer the data extremely fast between difficult mediums such as tape or object storage most recently, and high-performance file systems. And finally, it is a data policy engine. And that is what allows you to manage your space. You set it to a certain percentage, you set it to 70% utilization, and DMF will automatically manage the data at that level for you. So talking about data management, the perspective that we have at HPE is essentially this kind of an active and dormant data form. Active data form is where the data is processed, is where it's actively used by the CPU of the HPC cluster or AI cluster, and it's constantly changed, created, read, processed in different ways. And then the dormant tier is appropriately where the data goes to sleep, right? Where the data doesn't need to be processed and can stay in the background. And the most important thing is that for as long as it's there, it needs to be reproduced in exactly the same way that you've placed it into it. And that's the what we call kind of a cold data. So we also think about this as a front end and the back end. So the front end is a high performance file system. The back end is this dormant tier, such as tape, spun down disk or object storage. There are many use cases for DMF. I'm not going to go into them, but I can tell you that one classic use case is a bottomless archive to handle data tsunamis. If you have data tsunami coming at you, you do want to look at DMF and see if that can help you manage your data by tiering it as quickly as possible to the backend. That is a lot less expensive to manage. Also, it's a holistic data management solution. You can not only tier data vertically, but you can also move it horizontally. So you can move it across different file systems that may be sitting on different tiers of storage, such as, for example, flash, disk-based tiers, and it could be actually even a remotely located storage. Finally, dealing with the challenging workloads and burst buffers, DMF can help you place and stage the appropriate data sets into high-performance all-flash tier. So if we look at a little bit, click down what DMF can do. So first of all, DMF integrates with file system directly, meaning that it actually knows what the file system is doing. The files that are created, moved, deleted, changed in any way, DMF gets immediate notification of that and builds a reflection of that inside its own database so that it can be queried directly from the database as opposed to the file system. It is also a metadata repository that stores all the file system metadata, of all the file system that DMF is managing. It actually captures all the file metadata, including extended attributes and variety of other parameters of the file, such as ownership, such as file name, path, and so on and so forth. Data tiering is another aspect of what DMF does. So it actually moves the data between the tiers and transports data back to the high latency medium or object storage, and then reproduces it back in the file system namespace on demand. Job scheduler integration. This is where you can coordinate your staging of data into the parallel file system based on your workflow, based on your HPC scheduler activity. And finally, it's also offering a continuous backup, because as the data is migrated to the backend, it is effectively backed up. Now it exists in two places. It exists on the front-end file system and the backend medium, so it's in kind of a dual state, and it may have multiple copies in the backup medium, depending on the policy that is set. And that is what essentially constitutes backup of very large file systems. If you have a file system that is 10 petabyte, it's impossible to back up with traditional methodologies, but DMF can help you do that by simply running a policy and backing up all the files that haven't been backed up yet. It knows about them because it constantly monitors the file system. The software architecture is based on innovative big data technologies. We leverage Cassandra database, which is a scale-out NoSQL database, allowing us to be very scalable in terms of performance of queries. If we don't have enough performance, we simply add more servers that also bring in metadata storage with them. We use Spark Engine to actually perform the query, so we do that in a highly scalable, parallel fashion. We leverage the data movers that had been proven in the field for couple of decades, and the data movers perform the transfers of data between the front end and the back end tier. We leverage Zookeeper for configuration. We leverage Mesos for container orchestration, and Marathon for running container components. And of course, we have component level HA, meaning that if one of the nodes in our system happens to fail, then another node takes over that functionality. So you can see an example of integration with Lustre, and this is what we do with Exascaler from DDN. We have scalable database nodes that also include metadata storage, and we also have parallel data movers, and we can scale metadata storage for basically to what needs to be supported by the file system, as well as we scale parallel data movers based on the bandwidth requirement. And then we connect, as a backend, we connect either tapes, or we connect object storage, or even 0-watt storage that is a spun down version of the disk. So example of implementation with Exascaler 7000 is actually this configuration exists in our lab. And you can see that just 3 nodes with the database allow you to connect ES7K to a backend SUSE Enterprise Storage in this case, and it's essentially a generic object store that supports S3 API. Movers move the data, and database nodes collect the metadata and control the movement of the data between the front end and the back end tier. You can see here, this is essentially the file system that we have in our lab that is installed and is constantly being exercised. So this is a DDN about 250 terabytes of storage that we constantly populate and depopulate. So of course we support larger configurations with extra large configurations. All we need to do is add more gateway nodes, more mover nodes, and more DMF database nodes. And fundamentally we have ourselves a data tiering and data management solution. So in conclusion, I'd like to say that HP and DDN offer scalable solution for Lustre data management using DMF and Exascaler line. It is a highly simplified and streamlined solution that allows you to manage the file system in a unique way without additional components, directly plugging into the DMF framework. So the integration between Lustre and DMF is very tight. It allows you to save money by tiering your data to a backend or tiering the data to a high-performance flash storage. With that, I'd like to thank you. My name is Kirill Malkin. I'm with HPE. I'm Director of Data Management and Storage, focusing on software. My product is DMF Suite. If you have any questions, you can reach me either at the show or via my email on this, on this slide.